In this lesson, we are going to learn how to use our midpoint, distance, and slope formulae to set up coordinate proofs. Before we get started, let's talk about a few general rules. There are 4 simple rules. The first is to know your definitions. You need to know what a rhombus is. You need to know what an isosceles triangle is. These definitions help us determine good coordinates. Other things that help us determine good coordinates is what we are trying to prove. For example, if you know you're going to be using midpoints or bisectors, or if you're going to be working with diagonals, those will also help you choose good coordinates. Third, use the origin. We'll talk about that a little bit more, but you want to put your shapes on or near the origin. And finally, use the axes. Once again, put your shapes on or near the axes. Now that we know these 4 simple rules, let's see why we have them and how they work. Let's place a figure on the coordinate grid. Let's start with a simple scalene triangle. Definition: there are no congruent sides. That means all the coordinates are unrelated. So we get coordinates that look like this. Each vertice has a different pair of coordinates. Since this triangle is in the 3rd quadrant, all of these coordinates are negative. We have 6 variables because we have an x and a y coordinate for 3 different points. It gets really messy. So let's see about moving it someplace else, say the 4th quadrant. Notice that the x coordinates are all positive. However, the y coordinates are still negative, and we still have 6 variables. If we move it up into, say, the 2nd quadrant, doesn't get any better. We still have 6 variables. Moving it over into the 1st quadrant eliminates all the negative signs, but notice how we still have 6 variables. That is very annoying. It's very difficult to work with. So that's where our 3rd rule comes in. Use the origin. Notice that by using the origin, we eliminate A and B, because now the coordinates of that vertex is 0, 0. We do still have 4 variables, but 4 is a lot easier than 2. And now let's take a look at what the 4th rule does for us. We're going to use the axes. In this case, we'll rotate it down so one of the sides is on the x-axis. Notice that we just eliminated the variable f. So we have gone from having 6 variables, all negative, to having only 3 variables and all of them positive. As you can see, following these 4 simple rules can make your coordinates much easier to work with. Now let's take a look at altitudes. Here we have our scalene triangle, and if we draw in the altitude from the vertex, we're going down to the x-axis, but we're going to shift the triangle so that that top vertex is on the y-axis. Notice we still have 3 variables. Yes, the a is negative, and some people might argue that this does not use the origin. However, it does. It uses the origin a little bit differently. Notice when we drop the altitude in from the top vertex, we end up with the point 0, 0 for the other coordinate of the altitude. So not only does this setting use the origin, it also uses the y-axis. So remember, a vertex is not the only way to use the origin. Now let's see what happens as we talk about using midpoints. Notice how I've gone back to the original setting for this scalene triangle. We're using the origin of 0, 0 for one of the vertices, and the other 2 vertices use completely different variables because it's a scalene triangle. Now there are certain keywords that point to using midpoints. Obviously the word midpoint, but the word bisect, when we're bisecting a segment, often talks about using midpoints. And finally, mid-segment. Of course, a mid-segment is a segment that connects 2 midpoints. So all 3 of these words clue you into the idea that we will be using midpoints. Now let's find the midpoint of the left endpoint of that mid-segment. Using the midpoint formula, we are going to add our x and y coordinates together and divide by 0. So now we can simplify. Anything plus 0 is just whatever you started with. So the coordinate for that point is a over 2 and b over 2. how many of you like fractions? They can be very difficult to work with. What we often do is use a trick. And this is a place where choosing good coordinates becomes very important. We can replace those top coordinates instead of A, B. Let's call them 2A and 2B. All that does is it guarantees that you can easily divide things by 2. So now let's take a look at the midpoint of the left coordinate. So notice we have 2A plus 0 over 2, 2B plus 0 over 2. We can simplify that into 2A over 2 and 2B over 2, but notice what happens to all those 2's. They reduce out, leaving us with A, B as the coordinate of that midpoint. Now, we can do the same thing with the x0 there at the lower right. We can change that x to 2x. And now we can find our other midpoints. So at the right of the mid-segment, we have 2a plus 2x over 2 and 2b plus 0 over 2. Now that 0 doesn't affect much, and notice that by dividing by 2, all of the 2's go away. So our x-coordinate is a plus x, but don't worry about that. Everything works out with algebra and it's wonderful. And our y-coordinate is simply b. And then if we look at the midpoint on the bottom, we can just simply say x0. Because x is halfway between 0 and 2x, and of course the y-coordinate is 0 because it's on the x-axis. So notice that whenever you want to use the word midpoint, or bisect, or midsegment, times all of your coordinates by 2 to help eliminate the problem with fractions. So that's an introduction to the basic 4 rules.